So the negative power didn't cause you any issues, which was awesome. But we also have to remember these fractional indices rules. So this is the general rule here. So if you have a fraction as your power, remember the top number is your power. Okay, it's more powerful. It's on the top. And what's the bottom number? The
square root.
The root. Good. Not always square root, because it's obviously sometimes other things. And why is it helpful to remember that the root one is on the bottom of the fraction? Where do roots grow?
Down.
In the ground. Okay? So the root is the bottom of the denominator, the bottom of the fraction, and the power is the top. Now you're probably going to get the expression in this format. Okay, so you have to work backwards. So you have to remember where the numbers have to go. Is it going to go on the top or the bottom? If there is no number here where this n is, but you've got the square root sign, what is the value that goes on the bottom of the denominator? 2. Good. Because remember, in a square root, we don't ever write the 2, but it's secretly there. So you can have either of these two formats. Both of them are equivalent. So the power can be inside the root, or it could be outside. Okay, both of these two here would be rewritten as a to the power 2 over 3. Okay, so you've got to be confident at changing from root form to power form. So if I had 3 root x, I would have 3x to the power 1/2. Now, the bum thing here is that we now have to deal with multiplying by fractions, because we're going to now have to multiply our power by the coefficient in front. So you also have to remember you're going to take 1 from the power. So you're going to have to deal with fractions subtracting 1. Now this could all be on paper 1. And remember, paper 1 has no calculator. So you do need to make sure that you are confident and competent at using manipulating fractions. So this first one should be pretty straightforward. It's just a half. So we've got 3. So note this expression said fx. So I'm showing that I'm differentiating because it's got the f dash x. So I've got 1/2 multiplied by 3x. What's 1/2 take away 1? -1/2. Okay, I'm going to simplify that a little bit. So I've got 1/2 times by 3. That gives me 3 over 2. Okay, you can leave them as improper fractions. X to the -1/2. So that's my final answer. 3 over 2, x to the -1/2. Okay. I may as well do this as well. And so some questions have our direct fractions. Okay. In such cases, you need to separate the terms into 2 individual fractions. Now, do we appreciate that if I had 2/5 plus, let's do 2/7. If I had 2/7 plus 3/7, how would I join those together? I'd just add the top, so this would become 5/7. So I could write 2 plus 3 over 7. You agree with that? Yeah? So that means that if I have an expression that has 2 things on the top but only 1 denominator, I can actually separate those. So up here, in this example here, I've got 2 things on the top and I have 1 thing on the bottom. So that means that I can separate this expression here to be x squared over x cubed plus 5 over x cubed. You all happy with that? Mm-hmm. Now, it's slightly different if you have more things on the bottom. It's more complicated. So just be aware that these are more likely the ones that you would have. So whether you've got more than 1 thing on the top. Now, once I've got this, I need to make my life as easy as possible. And I know that x squared over x cubed can be simplified. because I've got x times x on the top and I've got x times x times x on the bottom. So I'm going to cancel using laws of indices. So I've got 2 on the top, 3 on the bottom, which leaves me with just 1 on the bottom. Okay, now you may prefer to go from this one straight to this one, to be honest, because you've got 2 subtract 3 gives you -1. Okay, so this middle one may be a bit more confusing. Can we do anything with this 5 over x cubed?
No.
No, because there's no x's on the top. Therefore, all we would do is rewrite it in the way we were just talking about, and we would bring our power from the bottom to be a negative power. Now note, we've had to do all of this work here before we've even tried to differentiate it. So if you're asked to differentiate expressions like this, you need to show all these steps of working. Try not to do too much in your head, because that's when some silly mistakes are made. So our derivative of that expression, therefore, would be what?
X is -1. Oh, right, derivative.
No, derivative.
-15x. What did not do that?
We've got this term here first.
Oh, negative
-1x, yes.
2.
Yeah. -2, yeah.
Plus minus -15x.
-4, good. Okay, note I've just changed where it had plus up above. Because I've got +5 multiplied by -3, I've just written take away. Okay, so this is my derivative. No, I haven't written dy dx or f dash x because this one doesn't even have a label. So I've just said derivative is equal to. Right, this next one is a similar situation. I've got several things on the top, 1 term on the bottom. So my first step is going to separate them. So I would have 2x cubed over x plus x squared over x plus 1 over x. Simplifying that gives us what? 2x squared. I'm not going to write over 1 if you're happy with that, yeah? Plus x. Yep, okay, plus 1 over x. Now, what do we have to do with this before we can differentiate? Good, we need to change this one here because we don't like them as fractions. So this is 2x squared plus x to the -1. Now we've done that work, we can now differentiate. So Skylar, do you want to do the whole thing for me? Nice. Almost.
-1. -x.
-2. Yeah, you got there. You got that. Okay, you're happy with that? So I couldn't pick on her. She got this one right. Okay, so remember, if it's just plus x, there's a secret 1 in front, so it'd just be plus 1. Good, excellently. Able does